Longtime Discovery Institute friend and personal friend, Matt Schultz, who is himself a startup entrepreneur, and we're joined by him now. Matt, good to see you.
Great to see you too.
Okay, so we're just talking. So you and I started at Discovery Institute about the same time. I started in '98. I think you were an intern, right?
Yeah, I was an intern. I was still in college.
You were a young guy. Yeah, a really young guy. And so, so we were very, very young then, and you were especially young. And so you've gone on to start a couple of amazing companies, Immusoft, and then Oishin Biotechnology, right? To have the
Oishin?
Oishin. See, so what's with this difficult name?
Well, it wasn't actually my idea.
Okay.
I won't take credit or blame, I suppose, but it was actually from Gary Hudson, who was the first CEO of it. And we actually met at an event, and I was talking about Immusoft. And one of my long-term goals for Immusoft, with this, kind of engineered B-cell therapy that was making app stores for the human body, was to recreate the biochemical environment of youth as you aged. And so I was giving a talk on this, and right after I spoke, a prominent scientist in the field, Judy Campisi, was presenting some data on these transgenic mice that let people clear senescent cells from them.
Okay.
And as this data came out of the Mayo Clinic in the Buck, and it was really influential in this nascent field. And I was listening to it, and I looked at the guy across the table, and I was like, that's amazing, but I would do it totally differently. And at the bar afterwards, he's like, well, how would you do it? And it kind of spit out this idea for what would become Oishin. And he said, we've got to do it. We got to build a company around this. And I had just completed the Series A for Immusoft, and so my investors will string me up if I start another company. And he's like, you write it up, I'll fund it, I'll run it till you can take over, I'll raise more money. It has to happen. And he had been saving this name for decades. And so he was a space guy. He's older than I am. And back when he was interested in longevity and aging, everyone said that is just a career killer. You don't even think about it. And so he went to space, but he was like I think he funded the first SENS conference. He always had a real passion for it. He's part of Methuselah Foundation back in the day. And so he was, and he's like, I want to call it Oishin. And I was basically, well, if the domain name's available, knock yourself out. I was like,
and of course it is.
Yeah, people will learn it. I was like, it's cool enough that we don't need it to be super catchy.
Yeah.
And so that was the
That's how you got it.
Yeah.
Okay, and so you've been at this for a while.
Yeah.
And so what I want to do is actually just kind of make some distinctions. People often sort of run things together, and so of course we had the inimitable Ray Kurzweil that spoke here, and so he connects a lot of dots. Let's put it that way, and it ends with us all kind of uploading ourselves into rejecting this mortal coil for this a more durable hardware, I guess would be the way to put it. And so longevity research, anti-aging, all these things that kind of get bundled together. So help us sort of sort these things.
Well, yeah. So you can think of it on one kind of extreme end of it,
right?
Just attempting to mitigate the decline, accumulation of damage, and loss of function we get as we age, and things that very much line up with things you can build drugs for. So even we're doing now, like we're making old people stronger because physical strength counts for a lot. As you kind of move down the spectrum, you have this idea of longevity escape velocity, which is effectively we'll be able to have enough medical breakthroughs that you end up gaining at least a year of life for every year you lose.
So that it just basically cancels itself out.
Yeah, and eventually we're making so much progress that we're winning the war against decay. And then I guess you have kind of biological immortality, which is the idea that if you could cause your body to regenerate well enough, you would effectively be immortal. Not invincible. You could still die. Of course,
exactly.
But, that you would have negligible decay, and it'd be basically you'd be 30 forever.
You're Elrond.
Like death becomes elective. This kind of thing, and so, but it's still very much. Fixing the meat bag.
You're still mortal.
Yeah,
you're just not whatever is happening with aging. You quit doing that stuff.
Yeah, and if you go closer to Kurzweil stuff, is you're actually trying to achieve immortality by getting rid of the human form.
The body.
So you put your consciousness into some kind of other vessel and go about that way. And this you have the versions of transhumanism, I guess broadly, that go into this. And I think, I'm not nearly as optimistic, having worked in technology for a long time. Humans actually live a long time. They're pretty robust. And one of the things that had enticed me about the field, really, was that there's nothing I'd encountered in computer science that really rivaled the complexity of even a single cell, let alone, humans.
Yeah.
And there is a weird middle ground, though, I guess, in that I think that humans are, effectively destined to control their genetic fate. Like we're ever since we existed, assuming we didn't wipe ourselves out first, we would effectively begin to manipulate the code of life, and that means that at some point humans aren't going to be what humans are now, and because
at least genetically.
We're going to.
And of course, I want to make a point here though, because some people hear that and they say you're saying we're going to transform human nature, but you don't think that everything's in the DNA. You're talking about at this point, sort of the genetic substrate that codes proteins and things like that. That's a different question from the entire human.
Yeah, well, the thing that's most interesting to me really is not so much the protein coding areas, but the control logic in life. Because I mean, you have effectively the same genome at 70 that you did at 7. And I mean, there's of course, somatic mosaicisms and stuff, you get damaged, but you still have like the same basic protein coding DNA. But you still accumulate damage and your tissues stop regenerating. And so I think the manipulation of that, like a holy grail of sorts in the field is this in situ tissue regeneration. Can I make an old tissue young again?
Right.
And you're probably going to have to make some hardware changes here, or at least changes the firmware. This came up in the panel of
what software was. I thought wetware.
Yeah. And I think everyone agrees that the chemistry of life is more or less a hardware. But when we were talking about software in two different lenses, one being the DNA itself, and the other being bioelectric control of that software. And I think it's an interesting point that I guess came up because we have an interesting group on the panel.
Yes, we certainly do.
But yeah, you could envision a world where humans physiologically are quite different than they are today, but you're still like flesh and blood, and the example that I've been paying the most attention to lately has been the bowhead whale. It's the only mammal we know that outlives us, and it outlives us by a lot, almost double. Like at least 200 years they live.
Wow.
And so the question is, okay, well, how does it live that long and not decay the way we do?
And it's quite large.
Yeah, it's huge.
Yeah.
And so it's a mammal, high metabolism,
Yeah.
and it's swimming around the ocean, and we do all sorts of bad things to the ocean.
Yeah, exactly.
It's there for the ride. So there's whales, bowhead whales swimming around today that were swimming around when Thomas Jefferson was president. And I think an awful lot's changed in that time, and they're still
happening.
Minding their business.
Yeah.
And, so some of the things we've been looking at with our collaborators primarily are the DNA repair pathways and the way that they manage and maintain their code and respond to damage.
Yeah. So what would you say has changed, or is anything changed or surprised you about your view from when you just first started this to now?
Oh, well, I mean, every kind of thing you examine is always way more complicated than you could have imagined. Even the simple things, like, it's crazy. I mean, stuff that you think or it looks like it's settled or understood, and the more you peel back, the more it's just, oh my gosh, I have no idea what's going on.
Absolutely. Yeah, if we knew how complicated things were, though, we'd never get started.
Yeah. I as I got into it, I never thought I would miss a debugger. Like in the world of computer science, you have a really complicated chip, like billions of transistors, but you could effectively freeze it in time and tell the state of every one of them. And it doesn't work that way in life. I mean, it's
moving.
Yeah, and it's parallel processing on an unimaginable scale in general.
Absolutely.
But yeah, we actually don't know what's going on in it. Like in computer science, pretty much all the bugs were either put there by you or your friends. These are man-made creations. Life, we just
It's
don't
unbelievable.
know what's going on.
Yeah, I mean, we still use these crude computer metaphors because they're the best we have.
Yeah.
They're also very crude, though, when we're talking about organisms.
For sure, yeah.
Matt Schultz, good to see you. Thanks for joining
Good to see
me.
you too.
All right.
Thanks.